So today we are going to be solving Cambridge IGCSE Chemistry Paper 2 Multiple Choice May-June 2023 Paper 23. So let's get started with question number 1. Okay. Nitrogen is heated in a balloon, okay, which expands slightly. Which statement about the molecules of nitrogen are correct? Okay. Basically, when we heat the particles, these are particles, and when we heat them, we increase their kinetic energy. So particles now move faster because they have greater kinetic energy. And because the balloon over here is expanding, okay, because it is expanding, that means particles move further apart as well. Okay, the average distances between the particles increased. Okay, which statements about molecules are correct? They move further apart. That is correct. That is why the balloon is expanded. They move more quickly. That's also correct, because when you're increasing temperature, always remember that you're increasing the speed of the particles. They remain the same distance apart. That's incorrect. If you're the same distance apart, then how can you expand? Their speed remains unchanged. That's incorrect. Their speed would have remained unchanged if you wouldn't have increased the temperature. Okay? Whenever you increase the temperature, you are always changing the speed of your particles. So the correct option is option 1 and 2, which is option A. Let's move on to second question, which says that the diagrams represent some elements, compounds, and mixtures. Okay, we have a group of elements, compounds, and mixtures. Look at each diagram very carefully. Okay, it will tell you either you have an element, a compound, or a mixture. Okay, the first one देखें. First one में all the particles they're similar. Okay, all particles are of the same size. Okay, we have the same size, and the second thing that's similar is their composition. Okay. हर particle में there are 2 white particles and 1 giant black particle. ठीक है? We have 2 white, 2 black particles. For example, if I say, I just make an assumption, this is H2O. Are all particles fulfilling the command that it's H2O? Are all particles fulfilling the order that it's H2O? Yes. Not even a single particle is disobeying the fact that it is H2O. How come? White are hydrogen. If I say white are hydrogen and black is oxygen, then all particles have 2 whites, H2, and 1 black, single O. That means my H2O is a compound. Then I can successfully say that this one is also a compound. Okay? Because all particles are of the same type and they're made up of 1 or more element. Okay? We can see 2 elements over here. That is why option 1 is a compound. Don't confuse it with anything else. Okay? Let's view option 2 as now. In option 2, the first thing I can see is my H2O particles again, which I randomly gave it the name H2O. Okay? It can be anything else. It can be SO2. Okay? ये sulfur dioxide भी हो सकता है. ये दोनों oxygen हो सकते हैं. Sulfur हो सकता है. It can be anything, but I randomly gave it the name H2O just to make it easier for you guys to see that all particles are of the same composition. Their chemical composition is same. 2 white and 1 black. That's the property of a compound. Now in element 2, not in element 2, in option 2, I can see that one is this thing and the second is this thing. These balls. What are these? Unfortunately, their chemical composition is not same as this thing. Okay? The chemical compositions have changed now. First, the chemical composition was this, and now this is also added to it. So this means that 2 compounds, okay, एक ये वाला compound and the second compound is this compound, are mixed together. Okay? They are mixed together. 2 different types of compounds. This is 1 compound and 2 compounds are mixed together. So what are substances called which have mixtures? Obviously they're called mixtures. So this is a mixture, okay, of compounds, because I can see ये भी compound है, ये भी compound है, because it has different types of atoms. ठीक है? एक ये white वाला और 3 white वाले और 1 black. Okay, let's move on to 3. We can easily tell that this is an element. Okay? This is a diatomic element. How do I know this is diatomic? It can either be O2, it can either be F2, it can be H2, it can be Cl2, any diatomic atom, a molecule it is. because I can see two same types of atoms that are covalently bonded. So that means this is diatomic. Now I come to this. In this, I have again a mixture. Okay, I know this is a mixture. How do I know this is a mixture? Because I can see different types of atoms over here. But this is not a mixture of compounds. How do I know this is not mixture of compounds? Because I cannot see, for example, if I had two more like this over here, I could say this is a compound because it had different elements. But over here, this is a single element, this is a single element, and two elements are mixed together. So this is a mixture of elements. So now let's choose the correct options. The first one was a compound, second one was a mixture of compounds, third one was an element, and the fourth one was a mixture of elements. Okay, so which makes it option B. Okay, let's move on. Two atoms X and Y have the same mass number, okay, but different atomic numbers. Okay, same mass number but different atomic numbers. This means that they are not isotopes. Okay, they are not isotopes. Why? Because the definition of isotopes is just reversed over here. Okay, isotopes have same atomic but different mass number. Over here they have same mass and different atomic. Don't confuse it with isotopes. Which statement about X and Y is correct? They have the same number of protons. How can they have the same number of protons? Proton number is basically your atomic number. It is told in the question that you have different atomic numbers. They have the same number of electrons. How can this be possible? Because your electron number is the same as your proton number in an atom. Okay? Because they're atoms. This means that we are going to have different number of electrons as well because we have different atomic numbers. They are in the same group of the periodic table. They have different number of neutrons. Acha. They are in the same group of the periodic table. Let's read the statement to know that how does we know about the group number. X and Y have the same mass number but different atomic numbers. How can this tell us about the group number? Group numbers are from your outer electrons, outer shell electrons. They basically tell about the group number. So this statement is insufficient to tell us about the group number. They have different numbers of neutrons. Okay, well that can be correct. ठीक है, that might or might not be true. ठीक है, ये भी हो सकता है कि ना हो. ठीक है, but this is the safest option among all these. ये ऊपर वाले तीन तो बिल्कुल नहीं हो सकते. D is possible. ठीक है, it might be possible because they have different atomic numbers and the mass number is same. So it can be possible कि उनके different number of neutrons हों. That's why. ठीक है, out of all these, D is the safest. So we're gonna go with D. Okay, let's move on. A sample of pure iron has 3 isotopes only. These are the 3 isotopes and these are their percentage abundances. This is important to calculate the relative atomic or relative atomic mass. And then we have the isotope and over here we have an N. The iron in the sample has the relative atomic mass of 55.9. What is the value of N? Okay, so now we have to find the value of N. Okay, so what are we going to do? We have a simple formula. Below we are going to take, in the denominator we're going to take 100, which is the total percentage. Agar in sab ka total kare that's 100. Then we're going to multiply each the mass number with the percentage abundance. So first it's going to be 54 times my abundance is 6 times 6, and then we add the other mass number, which is 56, times the other percentage abundance, which is 92. The thing over here is that we have to consider this third one as well. Okay, so what we do is that we basically add the third one as well. So plus, which is going to be 2 times n. So we can write 2n, and the answer of this entire thing, this is the way how we calculate the percentage abundance. You can say this is the formula for it basically. So the answer of this entire thing should be equal to 55.9. Okay, so that's what I know, that this entire thing should be equal to 55.9. Wait a second. Okay, so the answer should be equals to 55.9. Can we find out the value of n from here? That's easy. We simply have to cross multiply. That's a simple algebraic expression. Okay. First we're going to do 54 times 6. That will give us 324. Okay. Then we add to it 56 times 92. 56 times 92. That's going to give us 56 times 92. That's a huge number. 5152. And plus 2n equals to, if you multiply it with 100, that's going to go 1, 2, 5590. So 2n equals to 5590 minus 5152 minus 324, and 2n equals to, just subtract everything and you're going to get your answer. 5590 minus 5152 minus 324, and that's going to give you 114. N is equals to 114 divided by 2, and that's going to give you 57, equals to 57. So that means option C. So that is how we calculate it, by using a formula. Now some of you might think that there's another way of as well calculating it out. Some people can do it mentally as well. Okay, some people can do it mentally as well by looking at the percentage abundances and the isotopes. Okay, so it can be done mentally as well. So we're done with it. Let's move on. But it's very difficult when you have 3 isotopes to do it mentally. Okay, 2 isotopes it's fine, but 3 isotopes is way too confusing. So it's best to stay on the safer side and use the formula. Okay, let's move on. Magnesium oxide is a white solid at room temperature and pressure. Part of the structure of solid magnesium oxide is shown. Okay, Mg2 plus are magnesium ions and O2 negative is oxide ion. 3 statements are listed. Which statements are correct? Magnesium ions are smaller than oxide ions because they contain fewer electrons. That's correct. That's 100. Ek second. That's correct, but in order to show you guys that that's correct, we can check out the periodic table. Okay. Don't we have a periodic table over here? Oh, we have. Okay. Magnesium is basically, it has a proton number of 12. When it forms a magnesium ion, it has a proton number of 10. Okay? It has a proton number of 10. Oh, that's not correct. That's incorrect actually. I'm sorry. So that's why it's good to check. It loses 2, so it has a proton number of 10, and oxygen is 8. It gains 2, so it will have a proton number of 2. It will have a charge of 2 negative and a proton number of 10. 2 8 है, उसमें प्लस 2 कर दें, 2 इलेक्ट्रॉन्स उसने गेन कर लिए, 10 हो गए ना, तो दोनों के पास 10 इलेक्ट्रॉन्स है. So that's correct. Incorrect. Okay, it's good that I checked it out, because otherwise it would have confused us. So that's incorrect. We just calculated it out. We checked it out. Magnesium ions are smaller because the oxide ions not contain fewer electrons. Both have equal electrons. Magnesium oxide is has good electrical conductivity when molten because the ions are mobile. That's correct. The ions are mobile because these ions, which are held together in fixed positions, will get free. So you're going to have mobile ions. That is why it's going to be a good conductor. So option 2 is correct. Let's be option 3. Magnesium oxide has a high melting point because of the strong electrostatic attraction between the ions and the delocalized electrons in the giant lattice. Magnesium oxide is your ionic compound. Okay? Magnesium oxide is your ionic compound. In ionic compounds, basically the attraction is between the positive and the negative ions. It's not between the between the ions and the delocalized electrons. So that's incorrect. Hence, we find that only option 2 is correct. It's going to be D. In which molecule are all the outer shell electrons involved in covalent bonding? ठीक है, all outer shell electrons should be involved in covalent bonding. Definitely it cannot be this, it cannot be this, it cannot be this. That's easy. It has to be this. Why it has to be this? Because they can. Valencies, both are fulfilling each other valencies. How come both are fulfilling each other valencies? Look at ammonia. NH3. This is your N. These three are your H's. Okay? N is in group 5. 3 electrons are involved in covalent bonding. Because it's in group 5, 5 minus 3, 2 are still left in the N's last shell, nitrogen's last shell. So 2 unbonded electrons are still there. So all electrons are not involved in covalent bonding. Let's look at HCl. Chlorine is in group 7. So 1, 2, 3, 4, 5, 6, and the 7th electron is involved in covalent bonding. This is hydrogen. All the remaining 6 electrons are unbonded, not involved in covalent bonding. Hence, this cannot be a structure whose all electrons are involved in covalent bonding. Take care. Chlorine 2 maybe there are 2 chlorine like this, sharing one pair. All the remaining 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 electrons are unbonded. Whereas if you look in CH4, this is 1 carbon. These are 4 hydrogens. Carbon has 4 electrons in its outermost shell. Okay? Carbon has 4 electrons in its outermost shell. And 4 electrons, all those 4 electrons are involved in covalent bonding. This is carbon. This is first electron, second electron, third electron, and fourth electron. And hydrogen also has 1 electron. And all electrons of hydrogen are also involved in covalent bonding. Hence, there is no unbonded electron in this structure. Okay? Let's move on. Which row describes the property of silicon IV oxide? It's a giant covalent structure. That's correct. You should learn it from the syllabus. You have 3 giant covalent structures in your syllabus. You have diamond, you guys have graphite, and then you have this third one, silicon IV oxide. Okay, melting point. It should have a high melting point. Why? Because it's a giant covalent structure. And that's a property of giant covalent structure to have high melting points. Okay, which row describes the structure of a solid metal and explains the property? Which row describes the structure of a solid metal and explains the property? Okay, structure of a solid metal is, we don't have negative ions, we have positive ions in metals. Why? Because देखें, आपके पास ये आपका metal है, ये उसका atom है, ठीक है, ये आपका metal है. For example, this is sodium, ठीक है, ये sodium metal है और ये इसके 2 shells हैं और इसमें वैसे 3 shells होंगे. हाँ, 3 shells होंगे. For example, आपका random metal है, ठीक है, let's take it, ये आपका random metal है. अब now this random metal, which is I am naming X, basically loses its one. For example, it has 2 electrons in its outermost shell. This random metal loses its 2 electrons. Okay, these 2 electrons fly away or just move out, and when you have less electrons than protons, okay, when you have less electrons than protons, you form positive ions. For example, इसमें 10 ही protons थे और 10 ही electrons थे. But now 2 electrons are gone, so it has 8 electrons and 10 protons, so it's a positive ion. Okay, so it has to be a positive ion in a sea of delocalized electrons and conducts electricity because of the ions, not because of the ions, because of the electrons it conducts electricity. Ions are stationary. Always remember, in metals the ions are stationary, they don't move. Is malleable because the layers of ions can slide over each other. That's correct. You have your layers of ions, something like this. These are your positive layers, and basically these layers of your positive ions can slide over each other when you apply force on them. Okay, they can slide over each other. Let's move on. What is the formula of potassium oxide? It is going to be K2O, because they can. Potassium has a charge of +1. Oxygen has a charge of 2 negative. This 2 comes here, this 1 goes here, that becomes K2O. That was simple and easy, option D. Okay, moving on. A dilute aqueous solution of sodium bromide, ठीक है, एक वो सोल्यूशन है इज इलेक्ट्रोलाइज्ड यूजिंग इनर्ट इलेक्ट्रोड्स, ठीक है, which row identifies the product at the cathode and at the anode. What do you guys think? What is gonna be the products? We are having a dilute solution. So in dilute solutions we don't form our halogen. ये halogen है, halogen नहीं form होता dilute में, so it's not gonna be bromine. At cathode पे तो वैसे ही bromine नहीं हो सकती, anode पे it cannot be bromine, it cannot be hydrogen. At anode you have your negative ions, so it cannot be hydrogen. It cannot be hydrogen, it obviously has to be this option, ठीक है, because ये तीनों तो हो ही नहीं सकते. और उसके अलावा it's because it has sodium and sodium is more higher in the reactivity series than hydrogen, so hydrogen will discharge in preference to sodium because sodium is up in the reactivity series. It's more difficult for sodium to discharge, easier for hydrogen to discharge. Okay, aluminum is extracted by electrolysis as shown, ठीक है, this is the process of electrolysis. Which row shows the ionic half equations at the cathode and at the anode? ठीक है, अब होता क्या है कि what's basically happening in this electrolysis is this negative thing is your cathode, ठीक है, the negative thing is your cathode. At cathode you form aluminum, ठीक है, at cathode you are forming aluminum. So let's see in which equations are we forming aluminum. Either तो this is not the way we write equations, ठीक है, we need to write these. How can नहीं हाँ sorry एक second, हाँ this is not the way, sorry this is not the way we write equations. How can you take out 3 electrons out of a 3 plus sign which is deficient of, ठीक है, this is deficient of 3 electrons, ठीक है, इसको 3 electrons चाहिए और आप इसी में से 3 electrons निकाल के aluminum बना रहे हैं. If this was to happen तो फिर तो ये aluminum 6 plus हो जाता, ठीक है. If this was to happen it would have become aluminum 6 plus, ठीक है, this would make it aluminum 6 plus, aluminum 6 plus बन जाता है ये. क्यों? इसमें से 3 deficient है, आपने उसको 3 और निकाल दिए, वो 3 और का deficient हो गया तो वो 6 plus बन जाएगा. इधर वो 3 का deficient था, आपने उसमें 3 डाल दिए तो वो खाली aluminum 0 पे आ जाएगा. So option C and D are correct. अब हमारा जो एनोड होता है उसमें हम ऑक्सीजन फॉर्म करते हैं. लेट्स सी विच इक्वेशन फॉर द फॉर्मेशन ऑफ ऑक्सीजन इज करेक्ट. अच्छा देखें, ऑक्सीजन के पास दिस इज़ बेसिकली योर इनकरेक्ट इक्वेशन. ऑक्सीजन के पास 4 इलेक्ट्रॉन ज़्यादा हैं इस टाइम, 2 ऑक्सीजन के पास इट इज़ 2 नेगेटिव, 4 मोर इलेक्ट्रॉन्स, तो आपने उसमें से इलेक्ट्रॉन्स निकालने हैं उसको 0 पे लाने के लिए, तो यू कैन टेक आउट इलेक्ट्रॉन्स. इसमें देखें ये 2 नेगेटिव है ना, इसमें अगर आप 4 इलेक्ट्रॉन्स और डाल देंगे तो ये O2 नहीं बनेगा, ये O क्या बन जाएगा, O4 नेगेटिव बन जाएगा, 2O4 नेगेटिव बन जाएगा. आपने 4 इलेक्ट्रॉन्स अंदर और डाल दिए, ठीक है, वो 4 नेगेटिव बन जाएगा, ठीक है, पहले 2 नेगेटिव था, 4 और डाल दिए तो वो 4 नेगेटिव बन जाएगा, ठीक है. सो दैट्स इनकरेक्ट, हमने उसको 0 पे लेके आना है. सो दिस इज़ करेक्ट एंड नो वन एल्स इज़ करेक्ट, ठीक है. सो इससे बनता है कि हमारा ऑप्शन सी करेक्ट है. अच्छा लेट्स मूव ऑन. द रिएक्शन पाथवे डायग्राम फॉर एन एक्सोथर्मिक रिएक्शन इज शोन, ठीक है, ये एक एक्सोथर्मिक रिएक्शन हो रहा है. Which row identifies labels 1, 2, 3 and 4? ठीक है, ये एक एक्सोथर्मिक रिएक्शन है, मतलब हमारा ये जो हैं ये हमारे रिएक्टेंट्स हैं और ये हमारे प्रोडक्ट्स हैं. इफ़ दे वुडेंट हैव टोल्ड अस कि ये एक्सोथर्मिक है, हम खुद भी पता लगा सकते थे एक्सोथर्मिक है. रिएक्टेंट्स आर अबव, प्रोडक्ट्स आर एट ए लोअर एनर्जी लेवल. बेसिकली ठीक है, which row identifies labels 1, 2, 3, 4? 1 are reactants and 4 are products, ठीक है, ये और ये करेक्ट है, ये और ये करेक्ट है. दिस इज़ योर एंथैल्पी चेंज, ठीक है, हमारे रिएक्टेंट से लेके हमारे प्रोडक्ट्स तक हमारा एंथैल्पी चेंज होता है. सो 2 इज़ एंथैल्पी चेंज एंड लेट्स सी फॉर ये वाला ऑप्शन. हमारे रिएक्टेंट से लेके हमारे एनर्जी हम्प तक, दिस इज़ कॉल्ड एन एनर्जी हम्प, दिस इज़ योर activation energy. So reactants, enthalpy change, activation energy, products, all correct in one row is option A. Moving on, okay, this is going to be a tricky one. The equation for the complete combustion of ethene is shown, ठीक है, some bond energies are given. What is the overall energy change when 1 mole of ethene is completely burned? अच्छा, अब we are going to draw the structures because this is going to be tricky. अभी आपको समझ नहीं आएगा ऐसे अगर आप स्ट्रक्चर्स नहीं ड्रॉ करेंगे. सबसे पहले हम बनाते हैं अपना C2H4. C2 कार्बन डबल बॉन्ड कार्बन, H4 मतलब H and H. ठीक है, we are done with C2H4. Now we're going to draw 3O2 plus 3 times O2. देखें, जब भी आपको बॉन्ड एनर्जीज दियो ना तो आप इस वाली इक्वेशन से बॉन्ड एनर्जीज खुद से फिगर आउट नहीं कर सकते. ठीक है, आपको ऐसे बनाना पड़ेगा ताकि आपको पता चले कार्बन डबल बॉन्ड कार्बन एक दफ़ा है तो मतलब हम ये वाली एनर्जी लेंगे. तो इन ऑर्डर टू फिगर इट आउट यू नीड टू ड्रॉ इट. If you're very good at chemistry then you don't need to obviously, but if you're struggling with it you need to draw it. It will form CO2, 2 CO2, 2 times CO2. CO2 is something this, like this, carbon double bonded oxygen, plus 2 times H2O. H2O is something like this. So this is your H2O. Okay, so we are basically done with making it. Now we are going to calculate the bond energies. अच्छा, सबसे पहले let's calculate it out for this part. अच्छा, इसमें हमारे पास सबसे पहले कार्बन डबल बॉन्डेड कार्बन है. तो कार्बन डबल बॉन्डेड कार्बन सिंगल की है 612, so it's going to be 612 plus we have 4 CH bonds. ठीक है, 1 2 3 and 4. ठीक है, that's visible. तो हम कौन सा लेंगे, हम CH bonds को 4 टाइम्स ले रहे हैं. सो 4 मल्टीप्लाइड बाय 412. ठीक है, एक बॉन्ड एनर्जी को हम 4 से मल्टीप्लाई कर देंगे. सो प्लस 4 मल्टीप्लाइड बाय 412. ठीक है, यहाँ तक समझ आया. तो इस पूरे की हमारे पास आ जाएगी. अभी हम वो बाद में निकालते हैं. प्लस अभी हमें पहले हमें पूरे रिएक्टेंट्स की निकालनी है और फिर हमें पूरे प्रोडक्ट्स की निकालनी है. ठीक है, सो कैन ऐड इन इट 3 टाइम्स oxygen double bond. Oxygen double bond is 496 multiplied by 3. Why? Because we have 3 oxygen double bonds. So 3 multiplied by 496. अब इसकी पूरी टोटल एनर्जी निकाल लेते हैं. ठीक है, by putting everything we just have done into a calculator. 612 plus 4 times 412 plus 3 times 496, and this will give us 3748. ठीक है, अब हम निकालते हैं अपने रिएक्टेंट्स की एनर्जीज, अपने प्रोडक्ट्स की एनर्जीज, और फिर दोनों को सब्ट्रैक्ट कर देंगे. दैट्स इजी एंड सिंपल, बट द थिंग विच कॉम्प्लिकेट्स इज दिस, यू नीड टू ड्रॉ द स्ट्रक्चर. ठीक है, यू कैन नॉट डू इट विदाउट इट. अब 2 है हमारे पास कार्बन डबल बॉन्ड कार्बन. पहले हम एक कार्बन डाइऑक्साइड की निकालते हैं. एक कार्बन डाइऑक्साइड में हमारे पास एक कार्बन डबल बॉन्ड ऑक्सीजन है और दूसरा कार्बन डबल बॉन्ड ऑक्सीजन है. ठीक है, इन 1 कार्बन डाइऑक्साइड. ठीक है, 1 कार्बन डाइऑक्साइड में बेसिकली हमारे पास 2 कार्बन ऑक्सीजन के वो हैं. और तो 2 में कितने होंगे, अभी आप इसको छोड़ दें, आप बस अभी 1 का लिखें, फिर हम उसे 2 से मल्टीप्लाई कर देंगे. सो 2 टाइम्स फॉर 1, इसमें 2 टाइम्स एक ये है कार्बन डबल बॉन्ड 743 प्लस एक तो हमने इसका लिख लिया, अब एक हमें इसका लिखना है 743. ठीक है, बस 2 टाइम्स साथ लगा दें, कैलकुलेटर पे लगा दें, आपका आंसर आ जाएगा. फिर 2 टाइम्स लगा दें यहाँ पे. एक ऑक्सीजन हाइड्रोजन किधर है, 463 प्लस एक और ऑक्सीजन हाइड्रोजन 463. अब इस पूरे का कैलकुलेट कर लें. जस्ट पुट इट एज इट इज़ ऑन द कैलकुलेटर. 743 प्लस 743 प्लस 2 टाइम्स 463 प्लस 463, and that's going to give you 4824. अब आपने क्या करना है, आपने अपने रिएक्टेंट्स की एनर्जीज़ को माइनस कर देना है प्रोडक्ट्स की एनर्जीज से. ठीक है, रिएक्टेंट्स माइनस प्रोडक्ट्स. रिएक्टेंट्स हैं 3748 माइनस प्रोडक्ट्स की एनर्जीज हैं 4824. लेट्स डू इट. 3748 minus 4824, negative 1076. Option B. Okay, now we're gonna move to the next part. Okay, this was a difficult one, ठीक है? तो you should learn this entire thing, ठीक है? Let's move on. Magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen, ठीक है? Magnesium is basically your metal and hydrochloric acid is your acid, and you know metal plus acid forms magnesium chloride, which is a salt plus hydrogen, ठीक है? So that's a simple reaction which you guys have studied. Why does magnesium powder react faster than magnesium ribbon? Because magnesium powder has a greater surface area, ठीक है? More surface area. The magnesium atoms in powder have a lower, no, activation energy is not affected by this powder or metal thing, ठीक है? Powder has smaller surface area, not smaller, it is larger surface area. Magnesium atoms in the powder have more frequent collisions with acid particles. That's true. When you have more surface area, you have more frequent collisions, and that increases your rate. Magnesium atoms in powder have greater kinetic energy. No, kinetic energy is always determined. Remember, kinetic energy is always determined by the temperature. Okay, it's always determined by the temperature. If you change temperature, you change kinetic energy. So this is incorrect. This is correct. And powder, if you have a lump like this, that's all your surface area, okay? And but if you have powder, pieces of like this, your surface area increases. Now look, wait a second. This is your powder. Wait a sec. Now you are gonna witness it yourself. If I make, the surface area of this lump is all the yellow boundary I'm drawing. Okay, this is the surface area of the lump. But the surface area of powder, look, all the yellow boundaries. What do you guys think? What is going to be greater? All the yellow boundaries combined or the single yellow boundary? Obviously all the yellow boundaries combined, because now it has a greater surface area. Okay? If you combine these yellow boundaries, these smaller ones, they're going to be greater. क्योंकि देखें इसके अंदर वाला part भी expose हो जाता है by making it into powder form. So more reactant particles can collide. ठीक है? Which row shows the conditions used in contact process? This should be on your fingertips now. You use vanadium oxide catalyst. You use 2 atm pressure. You use 450 degree Celsius temperature. ये सारी conditions जो हैं ये हमारे हैं उस वाले process के लिए. What is that called? Your Haber process. ठीक है? This is your for the Haber process. और नीचे वाली है हमारे contact process के लिए. Moving on. A student heats hydrated copper sulfate, ठीक है, with the blue crystals changed to a white powder, ठीक है. How can the student reverse the reaction? By adding water. देखें, your copper 2 sulfate, ठीक है, you are heating it, copper 2 sulfate. When you heat it, it becomes anhydrous, ठीक है. This is your hydrated salt, and it becomes anhydrous. That means it loses water. But when you add water back to it, it becomes hydrated again. For example, just like take example of yourself. If for example you are like standing underneath sun on a very warm day, you become anhydrous, or you can say you become dehydrated. Your body loses water. How can you again become normal again? By drinking water, okay? By getting the water back you lost. So that's the same thing is happening. Add water to the white powder, it will become blue again. ठीक है, हीट करने से हमने उसका वाटर लिया, अब हम उसमें दोबारा वाटर डाल देंगे, it's going to turn to the same thing. Which reaction of hydrochloric acid is a redox reaction? Okay, what do you guys think? This one is going to be a redox. How did I exactly know in 1 second which is going to be a redox? Let me share this trick with you. Whenever, ठीक है, this is for like some reactions. Whenever you have a metal that is in oxidation state 0 and you see turning it into a metal, something with oxidation state different, that means that's going to be a redox reaction, okay? I just crossed all options. I selected this because of this magnesium. Only because of this magnesium, because it was changing its oxidation state in this one. because over here it was 0. Whenever you have an alone metal, ठीक है, alone metal which is in the products bonded with something, that becomes a redox reaction. Moving on, which oxide is amphoteric? ठीक है, in your syllabus there are two oxides which are amphoteric, aluminum oxide and your zinc oxide. So we have no zinc over here, we only have one option which is aluminum. 4 statements about strong acids are listed. ठीक है, which statements are correct? They react with carbonates to form carbon dioxide. That's correct. Acid plus carbonate is equals to carbon dioxide plus salt plus water. They completely dissociate in aqueous solution. That's correct. They completely form H plus ions. They react with ammonium salts to form ammonia. That's incorrect. Your alkalis react with ammonium salts to produce ammonia. They are proton acceptors. They are not proton acceptors. They are acids. All acids are proton donors, not acceptors. So it's going to be option 1 and 2, which makes it to be option A. Okay, which reaction mixture will produce a precipitate? Okay, how is precipitate produced? When you have a soluble salt, okay, when you have a soluble salt plus a soluble salt, okay, always remember soluble plus soluble will form an insoluble, okay. Let me write it correctly. A soluble, okay, plus a soluble, two soluble salts will form an insoluble salt, and your insoluble salt is basically your precipitate, okay. So we need two soluble salts to form the insoluble salts, okay. If we combine sodium carbonate and copper sulfate, so we're going to get copper carbonate. Is copper carbonate insoluble? Yes. So it's going to be option A. Sodium carbonate, soluble. Copper sulfate, soluble. Copper carbonate will be formed and sodium sulfate will be formed, ठीक है. तो copper carbonate तो insoluble हुआ ना, तो option A. Let me show it to you guys because you're not going to understand it that way. देखो, आपके पास है sodium sulfate और आपके पास है copper, not sodium sulfate, sorry, carbonate, CO3. सोडियम कार्बोनेट और साथ आपके पास है कॉपर सल्फेट. इससे आप फॉर्म करेंगे दो सॉल्ट्स. क्या होता है, ये वाला जो पार्ट है इसका फर्स्ट वाला और इसका सेकंड वाला कंबाइन कर जाता है, तो दैट विल बिकम सोडियम सल्फेट Na2, और इसका सेकंड वाला और इसका फर्स्ट वाला कंबाइन कर जाता है प्लस कॉपर कार्बोनेट. अब ऑल कार्बोनेट्स आर सॉल्युबल, all carbonates are insoluble except sodium, potassium and ammonium in group 1 carbonates. So copper carbonate is going to be insoluble. We had two soluble salts, two soluble, and we formed an insoluble. That's going to be option A, and this is going to be a precipitate. Okay, let's move on. Which set of elements shows the change from a metallic to non-metallic character across a period? From metallic to non-metallic character across a period. मतलब यहाँ पे हमारे पास सोडियम हो और यहाँ पे क्लोरीन हो. अक्रॉस अ पीरियड हमें मेटालिक से नॉन मेटालिक पे जाना है. बेरिलियम, मैग्नीशियम, कैल्शियम ये तो गलत है, ये तो अक्रॉस ग्रुप है. फ्लोरीन, ब्रोमीन, आयोडीन नहीं है, पीरियड तो नहीं है. ऑक्सीजन, बोरोन, लिथियम. फ्रॉम मेटालिक टू नॉन मेटालिक, ये तो नॉन मेटालिक टू मेटालिक हो गया. सोडियम, सिलिकॉन, क्लोरीन, दैट्स करेक्ट. सोडियम मेटालिक है, सिलिकॉन थोड़ा सा नॉन मेटालिक होते हैं. इट्स अ मेटलॉइड, it's a mixture of metals plus non-metals. You can say chlorine is a proper non-metal. Okay, a sample of ethanoic acid and a sample of hydrochloric acid have the same concentration. ठीक है, how do the hydrogen ion concentration and pH of ethanoic acid compare to those of hydrochloric acid? हाइड्रोजन आयन concentration जो है हमारे ethanoic acid में less होगी क्योंकि वो एक weak acid है. So it will be lower because it's a weak acid. Weak acids don't completely dissociate. If you have the same moles, same concentration, that means your moles in same amount of volume are same. ठीक है, फिर भी उसमें से dissociate बहुत थोड़े आएंगे. और जो आपका concentration है, देखें आपके हाइड्रोक्लोरिक एसिड का होगा 4 या 5, एथेनोइक एसिड का होगा 6-7. So concentration will be higher. And hydrogen ion not concentration, I'm so sorry, pH will be higher and hydrogen ion concentration will be lower. Moving on, what is typical property of a transition element: can act as catalyst, poor electrical conductivity, low melting point, low density. A. What they're asking about? Typical property. Poor electrical conductivity तो मेरे क्लोरीन की भी है. क्लोरीन भी क्या फिर ट्रांजिशन एलिमेंट है? नहीं. लो मेल्टिंग पॉइंट तो कार्बन डाइऑक्साइड का भी है, तो क्या कार्बन डाइऑक्साइड भी ट्रांजिशन एलिमेंट है? नहीं. टिपिकल का मतलब होता है जो सिर्फ उसी के पास हो. लो डेंसिटी तो मेरे हीलियम की है. हीलियम गैस एक्सट्रीमली लो डेंसिटी, less denser than air, rises up. So does that mean it's a transition element? No. It has to be a catalyst. All catalysts are transition elements. ठीक है, all catalysts are transition elements. Remember this. ठीक है. Moving on. Which statement about copper or aluminum is correct? Aluminum is more denser than copper. Aluminum is less reactive than copper. That's incorrect. Copper से ऊपर aluminum in the reactivity series. Copper is below, so copper is less. Copper has higher ductility. Copper has poor electrical conductivity. That's incorrect. Aluminum is more dense than copper. That's also incorrect. Aluminum is less dense than copper. Okay, aluminum is used to make your aircrafts. Okay, your aircrafts. This is, I don't know why it's not being made. Your aircrafts. I guess that's the worst plane you guys have ever seen. This is basically your airplane. Airplane is made up of aluminum. Why? Because we have to have something in air. We need it to float in air. So we need to make it as least dense as possible. So we make it of aluminum because aluminum is extremely least dense. So option C is correct, that copper has higher ductility. Why? Because copper, where is copper used? Do you guys know? Copper is used in wires. To make electrical wires, we use, this is a wire and this is made up of copper. And why do we use it? Because copper can be drawn into wires. Okay? So that means it's more ductile than aluminum. Okay, water from reservoir flows to the water works where purification process 1 takes place followed by process 2. What are processes 1 and 2? Okay, Asha. Okay, tell me one thing. You don't do fractional distillation with water, so ye dono to वैसे eliminate. Okay, out of these two, first, what are you gonna do? For example, if you have impure water, just consider it in your brain and you have huge particles, lumps in it of impurities. What are you going to do? First, are you going to add chlorine to it to kill the microbes and then filter it out, or first filter out and then add chlorine? Obviously, you're going to first filter out. You'll want the solid particles to first get removed and then you're going to add chlorine. And if you don't get this concept, then you need to learn all the steps in order for water purification. Okay. Achha, calcium reacts with cold water to produce hydrogen. Lead reacts slowly when heated in air to form an oxide but has almost no reaction with steam. Okay, it reacts slowly when heated in air to form an oxide but has no reaction with steam. Okay, silver does not react with either air or water. Zinc reacts heated with steam to produce hydrogen. Now we have to arrange it. First, obviously, it's going to be calcium because calcium reacts with water. So first calcium, then it's going to be Z because zinc because zinc reacts with steam. Then it's going to be lead because lead does not react with steam but it reacts with air. And then it's going to be silver because silver does not react with wo. But did you guys notice a mistake that I told all these in the reverse order? Over here we have to go from least to most reactive. So we're going to reverse our order. Calcium, zinc, lead and silver. Okay? It was important to read this and this. Okay, moving on. Blocks of magnesium are attached to the bottom of a steel boat to prevent rusting. Which equation describes the change that prevents steel from rusting? Okay, so what's going to happen is that this change. Magnesium is going to form ions. Okay? If we are preventing something from rusting, so we are preventing this Fe to react. So why would Fe react when you have your magnesium? All Fe, why are Fe even involved in these reactions? It's going to be option D. Magnesium is going to rust, or you can say corrode or form ions, but not Fe. Okay? Moving on, which statement about the extraction of iron in a blast furnace are correct? The temperature inside the blast furnace is increased by burning carbon. That's correct. You burn carbon to increase your temperatures. Iron 3 oxide is reduced to iron by carbon monoxide. That's correct. Close. Okay. The thermal decomposition of calcium carbonate forms slag. That's thermal decomposition. Nahi. It forms calcium oxide and carbon dioxide. Okay. Slag reacts with acidic impurities. No. It basically silicon dioxide which reacts with calcium oxide, and that's all a process. These two are not correct. So 1 and 2, which is going to be option A. Moving on, which statements about water are correct? Tap water has fewer impurities than distilled water. No, tap water has more impurities. Tap water will turn anhydrous cobalt chloride pink. Yeah, it will turn it. Any kind of water, okay? Tap water, sewage water, water from rain, any kind of water will turn it pink. Okay, the domestic water supply is treated with carbon to kill microbes. No, to remove tastes and odors. Phosphates from fertilizers can cause deoxygenation of water. That's correct, because phosphates basically cause algae bloom in the rivers. Okay, so they can cause deoxygenation, and that's a whole new process of eutrophication. That is not part of the syllabus, but you should know that it causes deoxygenation, but the process of eutrophication has been removed. So it's 2 and 4. That's going to be option C. Oxides of nitrogen formed in the car engines are removed by catalytic converters. Which equation represents the reaction that occurs in a catalytic converter? Okay. What you have is carbon dioxide नहीं हम react करवाते, carbon dioxide नहीं, carbon monoxide react करती है. So ठीक है. Why would you form nitrogen oxide? That's harmful. You're going to form N2 and CO2. So it's going to be option B. We don't form nitrogen oxide. That's harmful. We don't form nitrogen oxide. We either form nitrogen. And why would we form carbon and oxygen alone? That's incorrect. We form carbon dioxide and nitrogen. ठीक है. An alkene is represented by this formula. ठीक है. What is the name given to this type of formula? That's a structural formula. ठीक है. This formula tells us about the structure. So it's going to be option D. That's exactly telling us about structure, that where the double bond is present and how are carbons and your hydrogens arranged in this kind of atom. Let's move on. Not atom, sorry. Molecule. Okay, what is the structure of propanoic acid? 3 carbons we're looking for with double bonded oxygen and 1 OH. I guess this is propanoic acid. This is butanoic acid. We have 4 carbons in a row. So it's going to be option A. And these two, we don't even look at them because they are alcohols, not acids. Okay, butane reacts with chlorine in the presence of ultraviolet light. Basically, this is a photochemical reaction. Okay, learn this term, photochemical. I saw it in one past papers and where it was asked about the definition of photochemical, so learn it. It's basically a reaction which needs UV light. Okay, what is the equation for this reaction? Okay, you're not going to form H2. Okay, इसमें HCl बनता है. Okay, and you have butane. It's not going to turn C2. एक second. ये C2 क्यों आएगा? It will not. It will remain this. और बस एक हाइड्रोजन देखें, यहाँ पे 10 हाइड्रोजन है, यहाँ पे 9 है, एक हाइड्रोजन रिप्लेस हो गया है क्लोरीन से. That's a simple substitution reaction. ठीक है. A hydrocarbon P is cracked to make compound Q and hydrogen. Compound R is formed by the addition polymerization of compound Q, which homologous series do P, Q and R belong to. Okay, compound P is cracked to make compound Q and hydrogen. So P has to be an alkane because you crack alkanes only. So P is an alkane. So obviously, according to this, I guess only option B can be correct because P is not in any other thing. अच्छा, आगे पढ़ लेते हैं. Compound R is formed by the addition polymerization. हाँ, when we do addition polymerization of ethene, we basically form what are we forming? We're forming ethane. ठीक है, देखें सारे डबल बॉन्ड टूट जाते हैं. we're forming kind of, देखें जब हम ईथीन की पोलिमराइजेशन करते हैं तो हम फॉर्म करते हैं पोलीथीन. ठीक है, अब पोलीथीन क्या होता है? पोलीथीन बेसिकली होता है कि कार्बन डबल बॉन्डेड कार्बन नॉट डबल बॉन्डेड सिंगल बॉन्डेड कार्बन और हाइड्रोजन्स. बेसिकली डजंट दिस स्ट्रक्चर रिजेंबल टू ईथेन? सो दैट्स हाउ वी आर kind of making an alkane from an alkene. ठीक है, but the alkanes are joined together. So it's option B. ठीक है, हाइड्रोकार्बन P is cracked to make compound Q and hydrogen. P has to be an alkane. And compound R is formed by the addition polymerization of compound Q. This has to be option B. Okay, moving on. Which substances are structural isomers? Butene and propene, no. Ethyl ethanoate and butanoic acid. Acha, this might be. Methyl methanoate and ethanol. Okay, this might be propan-1-ol and butan-1-ol. This is incorrect. Option 1 is incorrect. And option 2 is incorrect. Option D is incorrect. We need to check for this. Acha. Ethyl ethanoate, let's draw it. Ethyl carbon or 2 carbons. Make it ethyl, and ethanoate also means that 2 carbons. And we have to draw the double bonds between them. So just erase this over here. We draw a double bond. O C C H H H H H H H H and H. So this अच्छा basically देखें, अब try to understand this thing कि इसमें हमारे पास हैं 2 oxygens. ठीक है, we have 2 oxygens. ब्यूटानोइक एसिड का फॉर्मूला क्या होता है? C4. ठीक है, C4H8O2. ये ब्यूटानोइक एसिड होता है, इसमें भी 2 ऑक्सीजन्स. ऑप्शन बी करेक्ट. मीथाइल मेथेनोएट में 2 ऑक्सीजन्स होंगी ना. मीथाइल देखें, मीथाइल मेथेनोएट. ठीक है, मीथाइल मेथेनोएट में भी 2 ऑक्सीजन्स होगी. यहाँ पे ऑक्सीजन होगा क्योंकि एस्टर है ये, तो एस्टर लिंकेज में तो 2 ऑक्सीजन्स तो आएंगी ना. और एथेनॉल का क्या फार्मूला है? C2H5OH, single oxygen, so it cannot be structural isomer of ethanol because it needs to have the same number of oxygen. Okay, ethanol is produced by the catalytic addition of ethene and fermentation. Which statement is correct? Both processes use similar amount of energy. That's correct. इस वाले में हमें बहुत ज़्यादा चाहिए होती है और fermentation में बहुत थोड़ी चाहिए होती है. Both processes use catalyst. That's kind of correct. देखें, एक में हम yeast डालते हैं और दूसरे में हम अपना वो डालते हैं H3PO4 फॉस्फोरिक एसिड. ठीक है, प्रोसेस 1 यूजेस टेम्परेचर ऑफ, नहीं, प्रोसेस 1 को बहुत ज़्यादा टेम्परेचर चाहिए होता है. 300 डिग्री सेल्सियस टेम्परेचर चाहिए होता है कैटालिटिक एडिशन ऑफ स्टीम को. प्रोसेस यूजेस नॉर्मल एटमॉस्फेरिक प्रेशर, सो इट हैज़ टू बी बी. बोथ यूजेस अ कैटलिस्ट. ठीक है, एक में हम यीस्ट यूज़ करते हैं एज अ कैटलिस्ट और एक में हम यूज़ करते हैं फॉस्फोरिक एसिड. ठीक है, 2 monomers shown can be used to form a condensation polymer. Which small molecule is released during this polymerization? It's simple. आप अपने कार्बोक्सिलिक में से OH निकाल लेते हैं और अपने एमाइन में से H निकाल देते हैं. जब आप ये चीज़ निकाल देंगे तो एक H और OH क्या बनाते हैं? Obviously water, so it has to be H2O. You don't even need to look at other things. ठीक है, dilute hydrochloric acid is titrated into a conical flask containing sodium hydroxide solution and few drops of methyl orange indicator. Which piece of apparatus is used to add the hydrochloric acid? आपकी एक चीज़ कॉनिकल फ्लास्क में, दूसरी चीज़ आप बीकर से डालेंगे. सिंपल टाइट्रेशन. मूविंग ऑन. ठीक है, मूविंग ऑन. The chromatography obtained from the chromatogram obtained from a chromatogram is basically your chromatography paper with separated components like this. From a chromatography experiment on substance S as shown. ठीक है, what is the RF value of S? RF value is basically first you take your entire distance from the baseline, the solvent in the denominator. ठीक है, just let's calculate it. This is 6 plus ठीक है 6 plus 4.7. ठीक है, ये डिस्टेंस हो गया. और फिर अपने यहाँ से लेके बेसलाइन से लेके एस तक का डिस्टेंस आप कैलकुलेट करते हैं, जो कि हो गया 6. तो जस्ट पुट इट ऑन योर कैलकुलेटर. एक हम पूरा डिस्टेंस लेते हैं ये वाला और एक हम बस ये वाला डिस्टेंस लेते हैं. सो 6 upon 6 plus 4.7 will give you 0.56. Option C. Moving on. Element X burns in air to form an acidic gas that decolorizes potassium manganate. ठीक है, acidic gas that decolorizes potassium manganate burns in air. Sulfur dioxide का टेस्ट होता है कि decolonizes potassium manganate. जब वो sulfur burn होगी air में, मतलब with oxygen it will form sulfur dioxide. और sulfur dioxide का, okay, if you know the chemical test, it decolonizes aqueous potassium manganate. So here we are done with the MCQs. I hope you like the video. If you do, subscribe to the channel, and that's gonna mean a lot. Bye bye.